Hello friends, welcome to my channel Code Blogs. In this video I want to tell you how to solve traveling salesman problem using dynamic programming. Okay, so you can say here I am taking an example. So basically to solve this problem we used a cost function to calculate the cost to travel between one city to another city. Okay, so now the cost function, cost of I comma s is equal to minimum of weight of I to j plus cost function of j to s. Okay, so here I means is it the starting vertex or starting city, and s is the remaining city. Okay, and here this one is cost from one city to another, and this is the recursive function. Okay, c of a to, if we try to find the cost to travel from a to another city. Okay, so a to s means b, c and d. So minimum of w of a to j may be in between of them, so I am taking b here, and cost function of b to remaining c and d. Okay, this is one possibility, and another two possibilities may be a to c and cost function of c to b and d, and another one is a to d plus cost function of d to b comma d. Okay, now we have to find the minimum cost to travel from a to another cities. Okay, so c of cost of a comma b of c of b comma c of comma d. So it have three different possibilities. First of all, weight of a comma b plus cost of b comma c d. Okay, this is first possibilities, and now second one, this is from a to b. Okay, traveling from a to b, and this is from traveling to a to c. And this is from a to d. Okay, this is from a to b, this is a to b, this is a to c, and this is a to d. And now again this is the recursion function. Okay, this is the recursion function, so you have two different possibilities. From weight of, this is the cost function. Okay, this one, so recursion function, so basically the weight of b to c plus cost function of c to d, and this is also b to d plus cost function of d to b, d to c. Okay, it also two different possibilities, weight of C to B plus cost of B to D, and again C to D plus cost of D to B, and it also two different possibilities. Weight of D to B plus cost of B to C, and this is the last one. So weight of D to C plus cost of C to B. Okay. So this is travel. This is the cost of traveling from A to B. This is B to C, and this is A to D. And now this is B to C. Okay. And this is B to D. And this is C to B. And this is C to D. This is B to D. D to B, and this is D to C. And now again recursive function, this one has one possibilities, weight of C to D plus cost function of D to, and there is no remaining one, so that is why we have to write 5. This one also one possibilities, weight of D to C plus cost of C to 5. This one also one possibilities, weight of D to B plus cost of B to 5, and this one also one possibility, weight of C to B plus cost of B to 5. And this one, weight of B to C plus cost of C to 5. Okay. Now I am calculating the cost. Okay. So from here we have to calculate the cost, weight of C to D, that means C to D, the cost is 9 here. Okay. So this is 9, and D to 5 means there is no remaining, that means it return to its starting city, that means D to A. This is the cost of D to A, this is the cost of C to A, this is C to A, this is B to A, this is B to A. Okay. So D to A, cost of D to A, that means 5. So 9 plus 5, so total cost for this section is 14. And now we have to calculate this B to C, weight of B to C is 13. So this is 13, so total is 27. So traveling cost from B to C is 27. Okay. Now here comes here into the D section, so waiting cost of D to C. D to C is 2, so this is the cost of 2, and C to A, the 5 means A, and so C to A is 4. So total cost for this C to D. Okay. This is traveling from C to D, this is D to C. So this is 6, and we have to find now B to D. Okay, B to D means 16, this is 16, so total is 22. And each and every section we have to find the minimum cost. Okay, we have to find minimum cost, to find minimum we have to find minimum cost. Okay, so in between 27 and 22, so 22 is minimum, so this is the cost to travel from B to D, and okay, and D to C, and again C to A. The total cost is 22, and again we have to find this cost A to B. A to B means 16. Okay, so this is 16, the total is 38 here, 38. And now this way we have to calculate the cost. So D to B, D to B means 12, this is 12, and this is B to 5 means B to A, B to A is 8, this is 20. So this is 20. Okay, this is 20, and we have to find cost C2 and cost of weight of C2D. C2D means 2. Sorry, C2D means 9. C2D means 9. So this is 29. And one more thing, I have to forgot to find this one. Okay, so this means weight of cost C2 B2D. Okay, so B2D means cost of B2D plus cost of D2 5. Okay, so D2 5 means D2A is 5, so this is 5, and B2D means 16. Okay, so total is, this is for 21, and we have to find this one. So cost of C2B means 7. So this section is 28. Now we have to choose minimum, that's why 28 is chosen here. Okay, and now cost of A to C, so weight of A to C means 11, so total is 39 in this case. Okay, and now in this here, so B to A and C to B. B to A is 8. Okay, so this is 8, and C to B means 7, so this is 7, so total is 15, and weight of D to C means 12, 2, so total is, in this case, is 17. Okay, and now we have to calculate this C to 5. C to 5 means 4, here 4, and B to C, so B to C is 13, so 13 4 means 17, this is 17, and weight of B to D to B is 12, so this is 12, so this section is 29, and we have to choose a minimum, that's why this section is called, the cost is 17. Okay, and weight of A to D means 6, so in this case its total is 23. So now, so traveling from C to another city, so we have to choose minimum, that's why this cost is 23 is minimum, so that total cost is 23. Okay, so the cost of from traveling from A to another cities and come back to its original city, that means returning to its destination, returning to its resource city. Okay, so total is 23. So traveling cost to travel from A to all cities and come back to again A is equal to 23. Okay, now we have to find the path. So path, we have to find the path, so this is the minimum, that's why we have to first we have to travel from A to D. Okay, and after that in between them, which is minimum, 17 is minimum, that's why we have to travel from D to C. So first of all A to D and then D to C, and now again in between them D to C. Okay, so D to C, after that we have to travel from D to C and again C to this. Okay, that means C to B here, so this is C to B. Okay, and again B to 5 means B to A, so path is A to D, D to C, and then C to B, and again B to A. So this is the total path. Minimum, this path required minimum cost to travel from A to all other cities and come again back to his destination, starting city. Okay, so this is the process of finding the minimum cost to travel all the cities using dynamic programming. Okay, that's all for this video.